Okay, so now that we've looked at the multiplication, the division or quotient, and the zero exponent rule and the negative exponent rule, the other rules are actually just based off of those. So I'll tell them and we'll get them all done in this lecture, and then we'll reserve the next one for doing some examples. So the next rule is the power rule for exponents. So the power rule for exponents. Okay, and what does the power rule for exponents say? It says that if you have x to the m to the n, well then that is x to the m times n. Now we can do a little example. We'll use the rule and then we'll look at it and see why does it make sense. So what this is saying is if you had x, say, squared to the third, well then that is like saying x to the sixth. Now why does that make sense? Well, x, let's break this down and do it slow-mo, right? So x squared, the x squared right there, that is x times x, right? And then you still have the 3, and that 3 says this is x times x, that's one of them, times another x times x, two of them, times another x times x, that's 3 of them, and you can see that that works out to be x to the 6th. So that's the power rule for exponents. The next rule is the power rule for products and quotients, if you want to combine those. So the power rule for product and quotient. And the power rule for product and quotient says the following. So for product, it says x to the, xy to the n is x to the n, y to the n, right? And the quotient rule, as you can imagine, is x to the n, y to the n. Okay, so that's the product and quotient rule. So again, let's do a quick example of each. So what this means is if you had a b squared, well that's a squared b squared, and if you had a over b squared, well that means a squared b squared. So there is though a certain sort of a, you can combine this power rule for product and quotient and the power rule for exponents together, and that's kind of a useful thing to notice. So what if you had a squared b cubed squared, right? Well, it turns out that this is, you can think of this as a squared squared and b cubed squared. And you can see how now we can use the first rule, the power rule for exponents here. So these two would give you a to the fourth, and then these two would give you b to the sixth. Now, does that make sense, right? You're sitting there going, well, does that really work? Well, let's see. So this is really, if we did this another way, this is really 2a squared b cubes. And if we use the commutative property to move things around and get there, and now we can use the, if when you multiply, you add the exponents rule to get here, which is the same exact answer we got from above. This is also true for the quotient. So if I had a squared b cubed squared, well then this is a to the fourth b to the sixth. So that's the power rule for product and quotient. And then finally, we have the expanded power rule. This again pulls together both products and quotients and essentially says it doesn't matter whether you have a product or a quotient. You get this. So, example of this one. So, what if we had 3a or a squared to the second? Well, notice that if you follow the order of operations, remember the order of operations thing we started with, you want to work inside the group first. So inside that group, we would get 3a, this is the 1, remember, 1 minus 2, so that's going to be 3a minus 1. Don't forget the 2 on the outside. And now we can use the expanded power rule or the power rule for a product, doesn't matter which way you want to think about this. You get 3 squared, and you multiply those two, and a to the minus 2. We can now do a little simplification of this, further simplification of this. 3 squared is 9, and we know that we can't leave negative exponents in your final answer, so this is going to be a to the second. There is your final answer. Okay, so let's do one more before we end this video and start looking at more simplification problems. What if we had this problem? 9a squared b sixth c 4, and all of that to the second power. Okay, all of that to the second power. Okay, so I'm going to use the expanded power rule. So before I do anything, I'm going to look inside here to see if I can use any of my rules to combine anything, simplify anything. Nothing combines or simplifies, so then I can move on to using the expanded power rule, which says, so there's a 1 there, don't forget the 1. So this working with numbers actually trips people up quite a bit. Because they inevitably will multiply 2 times 9 instead of multiplying the exponent. Exponents work with exponents. Keep that in mind, okay? Exponents work with exponents. So I've highlighted the exponents in this problem. So the 2 is going to work with the 1, 2 is going to work with that 2, 2 is going to work with that 6, and it's going to work with that 4. And the only thing I can do is do 9 times 9, which is 81. A to the 4th, B to the 12th, C to the 8th. Alright, that's it for all the rules, and so next time we'll take a look at problems, simplification problems, and how to navigate those.